Welcome back to factoring part 2. This one's going to be a bit more complicated because we're going to see something called factoring by grouping and when there's a lead coefficient involved. So if you didn't watch part 1 yet and you get confused in this video, please go back to that and make sure you get the basics down first, and we'll try to get a little more in detail in this video. So the first thing we're going to do is something called the grouping method. If you've never seen this before, the idea is that you're going to have things in 4 terms. So 1, 2, 3, 4 items here, the third, squared, first value, and then constant term. The idea is if it's in a group of 4 and there's nothing you can do with the entire object, remember our GCFs, there's no GCF in all of this. The idea is that we can break this into two smaller problems. So the idea is I'm going to essentially group off these first 2 and then group off those 2 and individually factor just the first 2 as a GCF, then individually factor these 2 as a GCF, and if we're lucky we'll get something nice to happen here. Won't always happen, and as you get good at this you'll see ahead of time if it's going to work, but the idea is if I factor each one at a time it might turn out nicely here. So let's just look at these first 2. X third, 4x squared, the GCF there, no numbers but there are variables in both, so I can take out an x squared from both of those. When the third is lost 2 x's, there's 1 left. There will just be a 4 left for this. And that's all I can do with these 2, so I'll leave that alone for now. Still got a plus here in between. In these 2 items, I have a 5x and a 20. There's a 5 that I could take out of both of those. And then I'll just have the x left here. With 5 taken out of the 20, there will just be a 4 left here. And this is the point where you have to look at both groups and see if it actually worked. So x squared and 5, those are both taken out. Both of these have x plus 4s. That's what you want to happen. You want these 2 inside values to match. If you do get that to happen, it's essentially like a double factoring step now. Since both of these groups have the same thing, I can pull it out as a common factor. So just like I did it with the 5s in here and the x's up here, I pulled those out to the front of the parentheses. I'm going to put a set of parentheses, and I'm going to pull the x plus 4s to the front of it. So x plus 4 is going to be sitting out front here, and then whatever's left when I take that away will be left on the inside of here. X squared is still here from the first group, plus 5 is still there from that group. Sometimes I'll be able to keep going with this. There's a squared here, so you might be able to break this down further. In this case, with a plus there, it's not possible, and we'll talk about why that is later. But x plus 4 is to the front. This is grouped out as well. This is as far as we could factor it. And so this is the grouping method where you group the first 2 and the last 2 and just continue from there. Alright, we're going to use this a little bit later, but let's look at the other situation that I wanted to get to, which is factoring with a leading coefficient. What I mean by that is a coefficient is a number in front of a variable. So this 2 here is a coefficient on the x squared, a 5 here is a coefficient on the x, this is the constant coefficient, and a leading coefficient means this 2 here. And there's always a number in front, but a leading coefficient other than 1. Like the last video we saw x squared plus something, whatever. X squared on its own is pretty easy. A number here throws this off a little bit. So really the trick that I use most is same as the last video. I start with 2 parentheses, and I ask myself, how can I make a 2x? It's not just x and x anymore. Now I need one of these at least to be a 2x, so that when I multiply these together, I get this term. And that doesn't do much except mess with my numbers here when I actually go to multiply it out. Because remember, we talked about how you can reverse the FOIL method to get back to this. When you reverse the FOIL method, whatever number is here is going to be multiplied by 2x, not a singular x. So it does open up some different possibilities here. Now I picked an easy one to start. The idea is, remember we were saying like what can add up to this while multiplying to be 3? Well, let's just try our options here. If 2 things are going to multiply to be 3, there's only one possibility. It's got to be 1 times 3. So let's go ahead and try both combos and see which one works. 2x plus 1 with x plus 3. That's one possibility. Or it might be plus 3 here with a plus 1 over there. Now normally that wouldn't make a difference. If these are both singular x's, it wouldn't matter which way I put the plus 1 and the plus 3. But again, in this situation, because I have a 2 here, that 2 is going to affect a 3 or a 1 in different ways. So let's do the FOIL method on both of these and just see what we get. If I FOIL out the pink numbers, I'll have 2x times x, that's my 2x squared, and that's what I expected, that's why I put a 2 here. 2x times 3 is going to be a 6x, 1 times x is going to be a 1x, 1 times 3 is going to be a 3, 6x and 1x is 7x's, that does not match my 5 here, so this is not going to work. The pink is wrong. Now that's no guarantee that the blue is right either, because maybe this problem just isn't doable, but let's test the blue and see if I didn't give us a bad problem here. So 2x times x, again, that's going to be 2x squared. No surprises there. 2x times 1 is a 2x. 3 times x is a 3x. 3 times 1 is a 3, and sure enough, here we are, 2x plus 3, that does match our 5. So the trick here is if there's a number other than 1, you really do have to fully think about all the possibilities and make sure you can break this down. So the plus 3, the plus 1 has to be in this order, or else it won't work, and your final answer would simply be written 2x plus 3 and x plus 1. And again, the more you do this, the more you're going to be good at it. You'll be able to do this in your head with the smaller numbers like this. The next one we do is going to be about as hard as it can get. So let's try one more example, and I'm going to do it both ways with this just kind of guessing game, and then I'll do it with the grouping method as well. So this one, as you may realize right away here, has a 6 in the front. On the last slide I did 2x and 1x. With a 6 you have a couple possibilities. It could be 6x and 1x, or it might be 2x and 3x. So already we not only have guessing games for the inside, but we also have guessing games on the front numbers as well. Now look at our last number here, 12. 12's got a lot of possibilities. It could be 1 times 12, it could be 2 times 6, or it could be 3 times 4. Any one of these could be matched with any one of these in any order. That gives you something like 24 different possibilities for how many ways this could happen. So let's just try the 6x and the x and just kind of guess a little bit here. In order to make a -1, there's a -1x here, it's probably not going to be 6 times 12 and 1 times 1. So we can kind of discard some of these. I'm going to guess that it's probably going to be the 3 and the 4 in some combination. And it turns out even 3 and 4 with 6 and 1 is not really going to match. 6 times 3, 4 times 1, that's not going to be close to -1 here. So I'm going to come back to this, and I'm guessing this isn't going to work. I'm going to try this one first, and if I can't get anything with the 2 and the 3, I'll come back, but I'm guessing it's 2 and 3. So same thing here. Let's try like 2 and 6, maybe 2 times 6 and 3 times 2. No, that's not going to work. It turns out it's going to be, in the ends, this 3 and 4 in some way. And actually, I meant this to be a plus, so that'll work a little bit better. Actually, no, it is a minus. Sorry. I was right the first time. So it should be, in the ends, 3x has the plus 4, and 2x has the minus 3. If you test that, you'll get 2x times 3x. That's our 6x squared, like we expected. 2x times plus 4 is plus 8x's. -3 times 3 is -9x. And multiply those, you get -12. So this will combine to be our -1. I kind of knew what the answer was, and I had a way to get there just by guessing, but this is where it's kind of a pain to do the guessing method. So I'm going to do the same problem again, last thing for this video. I'm going to do the same problem again with the grouping method now that we learned on that first slide. So if you forgot what that was, maybe rewind a little bit here and see. So same problem. I'm going to do this a little bit differently. So the grouping method is when you take the first 2 items and the last 2 items. I don't have first 2 and last 2. I have 3 things. I need to get this into 4. So the first trick to this is getting it into the correct 4 terms. And essentially it's going to be these 4 terms here, because then I can group these and group those. But how do you know to break -1 into 8 and -9? That's the first part of this. So the trick is you take the 6 times the -12, and you see what you get there. That's -72. And remember our basic factoring trick? We were trying to see what would add up to something while multiplying to something else. You're trying to see, okay, what will add up to -1 while simultaneously multiplying out to -72. It turns out you're going to want 8 and -9. 8 plus -9 will add to this number. 8 times -9 will multiply to be this value. So that's where you could figure out this 8 and -9 from. It's kind of weird, and there's a lot of math behind why it works, but the idea is it goes back to that basic factoring stuff. So I'm going to split this -x, this -1x, into 8x's and -9x's. I'm going to leave the rest of the problem the same. So this 6x squared is still going to be here. This is going to be a plus 8x, this is positive, this is negative, and the -12 will still be here. And now I'll do that grouping method that we did on the first slide. So I'll group these 2 together, I'll group those 2 together, and I'm going to put a plus in between here just so it's not wrong. So first two, GCF, I can't take a 6 out of both because 6 doesn't go into 8, but I can take a 2 out. So 2 comes to the front. I can also take an x out there. So 2x comes to the front. 3x plus 4 will be what's left. I have a plus here. I'm going to see that these are both negative, so I can take a negative out with my GCFs. I can also take a 3 out of a 9 and a 12. So negative 3 will come out of that. Negative 9x, and you take away the negative 3, you have a 3x left. Negative 12, take the 3 out, you have a plus 4. And again, this should match. If these two don't match, either you picked these numbers incorrectly, or you messed up the GCF somehow. But if you get this step, that's a good sign, because again, these match. And you can say, well, if I have common items, I can factor those out. I'll make a group for what's left, and I'll put this in the front of that group. So 3x plus 4 goes here. When I factor that out, what's left is the 2x and the minus 3. And this should look familiar. It's what we figured out on the last slide with a little bit of guesswork. But this is a more or less surefire way of getting there. It's a little more steps, but it always gets you there in about 3 steps here. If you can figure out this multiple number and then figure out the two numbers that match. So this is about as bad as it gets for factoring. Most ones we see this year will be more basic than this, but the grouping method is a good way to do it. If you have 4 items, you can kind of guess and check if you have 3 with a leading coefficient, and then if you're stuck with one like this where the number in front's got possibilities, the number in back has possibilities, you can always kind of combine the two ideas together and use this whole method here.